All right, so if you're a senior cloud architect, you're probably juggling multiple cloud environments, right? And you know the feeling. Trying to see the network traffic that's flowing between them can feel like you're just staring into a complete black box. Well, in this explainer, we're going to flip the lights on and show you exactly what's hiding in the shadows of your network. I mean, seriously, think about it for a second. You've got services running in AWS, GCP, Azure, all over the place, and they're all talking to each other. But are they doing it efficiently? Are they doing it securely? Are you missing those critical conversations that could explain why you're seeing a random latency spike? Or even worse, could be signaling a security breach? This right here, this is the fundamental blind spot in modern multi-cloud networking. So, here's our game plan. We're going to tackle this thing head on. First, we'll dig into the problem itself. Then, we'll introduce the revolutionary solution that is eBPF. After that, we'll look at some tools you can use today, see the incredible insights you can get from them, and finally, we'll zoom out and talk about what this all means for the future. Okay, let's get into it. Let's formally define this problem. Why are the tools we've been relying on for years, why are they suddenly just not cutting it anymore in this new, distributed, multi-cloud world? The old way, we had things like VPC flow logs. And they were useful, for sure, but they were always stuck inside a single cloud. And a lot of the time, they were sampled, which means you were only getting a piece of the picture. But the challenge now, it's a whole different ballgame. We've got containers popping up and disappearing, traffic hopping between different VPCs and clouds, and pretty much everything is encrypted. Your traditional tools, well, they just can't keep. So how do we fix this? The answer isn't about just adding more agents or more proxies. Nope. It's about going deeper. I'm talking right into the heart of the operating system itself. And the key that unlocks it all is a technology called eBPF. To put it simply, eBPF is kind of like giving the Linux kernel superpowers. It lets you run these tiny, super efficient, and this is the most important part, safe programs directly inside the kernel. This means you can see everything the kernel sees, every single network packet, every system call, without having to change the kernel's code or adding a bunch of overhead. It's an absolute game changer. And this is basically how it works in a nutshell. You write a small eBPF program, say to watch for network packets. Then you load it into the kernel. Now, before it does anything, the kernel runs it through this incredibly strict verifier to make absolutely sure it's safe and won't crash the system. That's the safety net. Once it passes, you just attach it to an event, like a packet arriving, and bam, your program can now see and report on that traffic with perfect fidelity. Okay, so the theory is cool, but how do we actually use this power? Let's take a look at the real-world tools that put eBPF to work, things that architects can go and implement right now. Two of the big open-source players in this space are Cilium Hubble and Pixie. Think of it like this. Hubble is your network and service specialist. It gives you these incredible service maps and flow visibility, all from a networking point of view. Pixie, on the other hand, is a bit more developer-focused. It's looking at application-level stuff like HTTP, DNS, even database queries, to give you really deep insights and application performance. They're really just two sides of the same very powerful coin. Okay, so we have the technology and we have the tools, but what's the payoff? What can you actually do with all this newfound visibility that you just couldn't do before? Well, first and foremost, you get complete flow collection. And this is huge because eBPF is sitting right there in the kernel. It sees every single packet. That means no more sampling, zero. You capture every single conversation between every service. Doesn't matter if it's inside one Kubernetes cluster or spanning across 3 different cloud providers. You miss absolutely nothing. But here's where the real magic happens. It's not just about collecting network data. It's about being able to connect that deep network visibility with your application-level traces. You can finally answer those impossible questions like, okay, this specific API call is slow. What was the actual network latency between the microservices that were involved? It completely bridges that gap between your infrastructure and your application performance. And of course, when you have a complete real-time fire hose of all network activity, the possibilities are just incredible. You can build a baseline of what normal traffic is supposed to look like. And then, the second something deviates, a sudden spike in traffic on an unusual port, or a service that suddenly tries to talk to the internet when it never should, you can detect it instantly. This is a massive win for both performance troubleshooting and for security. So to just boil it all down, the benefits for any architect are direct and they're incredibly impactful. You can pinpoint the exact source of latency between services in seconds. You can debug those super complex communication problems across cloud boundaries without all the friction. And you can spot security threats as they're happening, not hours or days later. So let's just zoom out for a second. This isn't just, a slightly better networking tool. What we're really looking at here is a fundamental shift in how we observe and understand our complex systems. This quote really just says it all, doesn't it? By giving us this safe, programmable access right into the kernel, eBPF has created a universal observation point. It becomes the source of truth for literally everything happening on a machine, and by extension, across your entire distributed environment. And that really leaves us with a final, pretty provocative thought. We've just seen how eBPF unlocks the black box of multi-cloud networking. But what's next? Think about it. Security monitoring, performance profiling, storage I/O. The potential applications are just massive. The future of observability isn't just about collecting more data. It's about getting that data from a more fundamental source. And that source is the kernel, unlocked by eBPF.